In this video, we learn about the exponential distribution, and the example I'm using is E. coli. E. coli are bacteria which reside in your intestine, and they help you to digest food. And there are good E. coli which help you, and there are bad E. coli which can lead to infections coming from dirty food, for example. E. coli are also the workhorses in labs because they are easy to keep and easy to manipulate and mutate and so on. So here we are interested in the cell cycle of E. coli. It has been measured that on average the cells divide every 22 days. So we said mu equal to 22 days. It also observed that the exponential distribution is a very good descriptor for the cell cycle time. Okay, so given mu, the exponential distribution then is given by 1 over 22 e to the minus 1 over 22 times t. And down here I show a graph of this function. It's a decaying exponential function. As this is a probability distribution, the integral over the whole thing from 0 to plus infinity will be equal to 1. Keep that in mind, we know this already. Now I like to answer two questions. Determine the probability that an E. coli cell divides in less than 20 minutes. And secondly, the probability that E. coli cell takes more than 30 minutes before it divides. First question, divides in less than 20 minutes. So what we have to do is, we have to find the probability that 0 is less or equal t less or equal 20. The probability density function is given, so then the probability is simply an integral. It's the integral 0 to 20 over 1 over 22 e to the minus t over 22 dt. Graphically, it is this area here where I integrate from 0 to 20. Yeah, let's compute this just quickly. We keep the 1 over 22, we do the antiderivative of the exponential, which is minus 22 e to the minus t over 22, and then all this between 0 and 20. Okay, so the 22's cancel, and then we sub in the 20, e to the minus 20 over 22, and then we sub in 0, so minus minus plus e to the 0. E to the 0 is 1, so then we get 1 minus e to the minus 10 over 11. And so now I need a calculator to figure this out, and the answer is 0.59711. So you would say 0.6. That means about 60% of E. coli cells divide in less than 20 minutes. On to the second question. The probability that it takes more than 30 minutes. So maybe we go to the graph first. So more than 30 minutes, here's 30 minutes. So now we are interested in this bit. Or written as an integral. P of t larger or equal 30 is the integral 32 to what? Well, to infinity, right? In theory, it can take infinitely long. 1 over 22 e to the minus t over 22 dt. So this is the same antiderivative we had before. We get 1 over 22 minus 22 e to the minus t over 22, and then this evaluated between 30 and infinity. So the infinity, remember, is always a limit, right? If we evaluate something at infinity, it needs to be seen to be a limit. So then this first term becomes minus the limit as t goes to infinity e to the minus t over 22. But then subbing in the 30 is no problem at all, so then we get plus e to the minus 30 over 22. Now what's the limit? Well, it's the exponential function with a negative exponent, so this goes to 0. And our result is then simply e to the minus 15 over 11, which then, if you calculate it out, is something like 0.25573. We can say approximately 26% of E. coli cells need more than 30 minutes to divide. Now for this part, there's an alternative way to compute it. And this is which I like to show very quickly here. So we do the 30 again, We want to know the probability to divide after 30 minutes. What we can do is we can compute this probability first, so the probability to divide within 30 minutes, and then subtract it from 1. So what I said is p of t larger or equal 30 is 1 minus p of t less than 30. And the reason is that this area and the area I computed before together give 1, because the integral under the curve is always 1. So then this would be integral from 0 to 30. Again, the same function, e to the minus t over 22 dt. So then let's do this super fast. I don't know how fast I can write. We did this antiderivative now for the third time. And so then this is 1 minus, and minus is plus, e to the minus 30 over 22, minus 1, the ones cancel, e to the minus 30 over 22. And this is similar to the 0.25573. Sorry, I got carried away.